Hello guys, this is Ravi Rajput. Today I have brought a very interesting topic here to discuss, that is agentic AI. And that is also very trending nowadays as well in an ML AI world, right? So just to begin with, you might have thought about what this agentic AI is, right? So even I was pretty curious to understand. So basically the agentic AI, what I could understand uh, is think about a list of tasks which you want to do, right? So for example, you are going to an e-commerce website and you went to a specific chatbot and give your query. That's chatbot, that's a bot, not a human, right? Which you are interacting with. You give a query, I want to buy Nike shoes within $1,000, right? So what it will do, it will bring you all the relevant SKUs or the products, right? The shoes within $1,000 range, and provide a list to you. You select one shoes which you definitely would like most, and provide that SKU number to the chatbot back, and okay, place an order for me. So it will go and place the order for you, right? So this just think a very high level scenario from e-commerce, right? So this is what this will be done by the chatbot, and this is what the agentic AI is, right? So agentic AI means to execute a certain set of instructions or certain set of tasks, right? So in a well defined order to execute any specific operation for you, right? So it's not a kind of a new AI thing where agents are specifically being trained, or fine tuned or whatever. So they are just programs which, like, where they are using the existing AI, or I would say LLMs, to do some reasoning, to understand what they want to do, and in what order, right? So that's the AI part, where they are just sending their queries and a list of tools to LLMs, and determining what needs to be done in what order. LLM is doing some reasoning. Right. So I would also explain what the tools are. So tools is a set of operations which you need to do, like placing the order is a tool, right? So place order or search product might be another tool, right? So to do any operation via agent, you should be having a list of operations or list of tools with you, which you should be providing to LLM for doing the reasoning, and LLM will give you the relevant tools what you need to do for a specific operation, right? So maybe you can have many tools, for example, right? And you said you want to buy Nike shoes within $1,000. So LLM will it will identify the relevant tools for you, like search products, the first tool, right? And then create cart, maybe the second tool, and place order, maybe the third tool, right? So, and in that order. So and these are all tools about, and definitely you need to define those as well. You need to define those functions. So tools are a kind of functions, right? So yeah, in order to complete the operation. So at a high level, what is the flow of agentic AI? Like, you give a query to agent will pass that query and a set of tools or the operations to the LLM. There is where the actual AI start, right? So LLM will do the reasoning. It will sort out the list of relevant tools for you, and probably the order, and give it back to the agent. Okay, use these tools, right, to do certain task, probably in this order. And again, like, tool will get that, yeah, agent will get that response from LLM and execute all those tools in an order for you to do the certain piece of task. So this is a very high level view of agentic AI, right? So today what I have done here, I also tried to achieve this using a very small POC. This is a very small POC, only for demonstration purpose for agentic AI, right? So maybe we can extend it beyond our thinking and go ahead with some real world use cases. But just to understand what exactly it is, so this will explain. I would try. I think this will explain you pretty much. Okay, so yeah, just to start with, the first part is like definitely importing the relevant libraries. So here I did like MCP. I'll cover what MCP is. So and the second is LangChain. LangChain is definitely a very very useful framework in AI ML world, right? So LangChain provide you a lot of wrappers which you can use with less complexity of code. You don't need to jump inside that complexity, right? So it will give you it will create a chain for you, right? For tasks, like it can be used for RAG as well, using retrieval QA, that library. You can develop the RAG examples as well, the like RAG use cases as well in LangChain. So just go and read about the LangChain. It provides you a lot of useful classes and a lot of useful wrappers to do all your machine learning tasks, right? So the LangChain I had imported, LangChain community, GPT-4 all. This is the model. I wanted to use some free model, right? So GPT-4 all I had used, and definitely you can go and think about any suitable model which you want to opt for your work. Like you can use OpenAI, and also going to the AWS world, there are multiple Claude, Sonnet, like those models are available in Bedrock, which you can use from there. But yeah, that's paid, right? So like this is a model LLM which will do the reasoning for the agent. And the last one is NetAsync. Don't go much detail in it, right? So this I have used only to support here only for Google Colab notebook, which I'm using, right? So because I may be doing some task in the background, right? So that's why I have used it. Otherwise, maybe if you're doing in the real world, right, you may not need this, right? Just think if you're having a multiple layers, one for MCP server, second for your LangChain where it is calling your agent. So one thing I had mentioned, MCP server. So MCP server is again I have developed this example using MCP only. So MCP server is a crucial part of your agentic AI flow. You should use it in a very clean, like to provide a very clean approach and industry level approach for agentic AI workflow. So MCP server stands for model context protocol. MCP stands for model context protocol. So why we use that MCP server? So as I mentioned earlier, like this MCP, see, this agent may need to call various external tools, right? Or maybe call various tools, or may need to call the external word, right? So where they should be accessing some different type of external services and different type of external databases, for example, right? So there the tool helps to agent, right? It provides a standardized layer or a standard, like tools don't need to directly interact with that external word. MCP server will do on agent's behalf. So agents it's a kind of one layer in between, right? So it provides the standardized protocol or a standardized layer where agent can interact with diversified services via a single protocol, right? So you like a kind of loose coupling, a kind of adapter for the agent, right? So it's an adapter. So that's the main purpose of MCP server, right? So and just to interact with the external world within a standardized protocol that is useful for agent, right? Maybe there may be more other uses for MCP server. You can go and explore about MCP, but this is the main thing, model context protocol, to provide the standardized layer. Okay, so now let me show you some code after importing it. So here I have designed like I have written some code about MCP server. Here I'm designing or I'm creating the MCP server. So one more thing about just another analogy, take the MCP server as a toolbox. Okay, so agent use different tools to do a certain operation for you. So all the tools are available in MCP server. So MCP server, you can say it as a toolbox for your agent. Okay, so here while creating the MCP server, I have defined the tools here. As I said, it's a toolbox, right? So just take the tool as a function. I might have mentioned it before, but again reiterating. So tools are functions, right? So it so for example, this get weather I have used, right? There can be place order, or there can be search product which might be calling some e-commerce API in it, right, and returning the response. So just an operation, a list, just an operation. Tool means operation, so list of tools means list of operations, right? It can be a function, it can be method, or whatever, right? Uh, yeah, I have defined two tools here in MCP server, right? So it's, as I said, it's a very simple example. So here I'm just trying to ask the agent to tell the weather in the city, and once the weather is predicted, then tell some joke to, to relax me or whatever. So like the two operations here, or the two tools here. Now the third thing comes, like here I'm starting the MCP server asynchronously in the background. So this is only for collab and notebooks, right? Only for demonstration purpose. But maybe in a real world scenario, if you are having MCP server maybe in different container, and other logic, rest of the logic in different container, and like you can start the container as a separate process. You don't need to worry about this asynchronous thing. So that's why I mentioned you not to worry about this async queue things. Just understand what's happening behind the scene, right? Just yeah, what's happening here. So MCP server, I'm starting the MCP server using mcp.serve, right? So start MCP here, and finally the MCP server started, or it is running, right? So once it is started, like half of the things are done. So you have your toolbox available, which agent can use to query the LLM and get some sessions from there. Now here the actual thing starts. So again, I just provided additional functions, like this is a kind of wrapper function where I'm defining one operation which is inside calling the MCP tool, right? So what agent will do, it will call this function, and this function will call the MCP tool. You can do it directly, but it's always good to provide additional loose coupling in your code. So that's what it is happening here, and a list of tools, right? So this is a list of tools, available tools I had given here. Get weather is the first tool, tell joke is the second tool, what is the corresponding function for that tool, and with the description. Like third thing, imported the required libraries from the LangChain community. I have used LLMs, like I imported GPT-4 all. Then definitely the tool class, agent type and initialize agent. You will see how we are using it. And from the GPT-4 all model, I'm using the Mistral 7, like might be a bigger model, right? So you can use, if you are in the real time use cases, if you need a bigger model or smaller model, you can use accordingly. So here I have used a Mistral model, which is 4 gigs in size, and maybe, yeah, took little while to download. Yeah, once the model is downloaded, then imported other you packages for agentic AI, that is zero shot agent. So this is interesting thing, guys, like zero shot agent. What is this? So there are different types of shots available in agentic AI. One is zero shot, other one is few shot, one shot, right? So that tells your agent how to query the LLM, right? So um, for example, in zero shot, it means it's a zero shot. You don't need to provide, and you will not provide any example to LLM, right? So it will do the things for you. It will try to do the reasoning based on its own understanding, right? So zero shot means no example. One shot means with one example. Few shots means like few examples you will provide to LLM to do some query. So here I have used a zero shot agent. Okay, so but yeah, I had also provided one example, so you can say a one shot agent, not actually a zero shot, right? So zero shot with one example I have used. You can definitely go and optimize this based on your need. If you want to, if you have a little complex use case, you think that you should provide some examples to LLM to do the reasoning in a way you want it to do, then yeah, you can go with a few shot, right? But here, like simplest is the zero shot. So this is the example. I want the LLM to provide the output in this way, right? So what is the weather in Paris, and tell me a joke. I thought first I get the weather and tell a joke. This is thinking of LLM. Okay, then get weather. It will call a tool for get weather. Whatever the input is, Paris. Paris, and the weather in Paris is cloudy and 15 degrees centigrade. Now I will tell a joke. Tell joke is the tool which it identified. Okay, action input, it may not have any input. Why did the AI go to school? This is just a joke I designed uh, to improve its neural networking. Okay, just take it as a joke, right? So, and now the thought is I have completed all steps. Final answer: the weather in Paris is cloudy and 15 degrees centigrade. Here is the joke. Why did AI go to school? Blah blah. So this is an example. I want the agent to respond in this way in order to complete a set of instructions. Okay, so this example I will pass to LLM prompt, in order to do the reasoning in this desired way. Like, and again, this is tool strings. I'm making all the tools, like combining all the available tools from list to a string, right, to pass it as a prompt. A prefix, like prefix plus prefix, guys, in agentic AI, it's a prompt, right? So it's a initial system level prompt which you will pass to your LLM, and that is like, you are, for example, you are a smart agent, you are a yeah, you are a smart e-commerce assistant. Just try to answer, these are the available tools, try to answer in an effective way, or try to answer in a polite way, or whatever, right? So that those are the initial instruction you will give as a part of prefix. Suffix is like, this is a user input. And agent scratchpad, which is like agentic AI term, where it's an scratchpad where agent note all the past conversation, whatever it has done with the user. So that is all done in the agent scratchpad. This is an out of the box term, or out of the box thing which is used in the agentic AI flow. So this is used as a part of suffix. So here you would see, like, prefix, I'm passing the initial instructions, right? I'm not providing any specific instructions like the manual instruction. It will be the default one, right? So I'll be printing it. You will understand how that those look like. Suffix with the example, I have appended the example with the suffix, right, and the input variables. Later, to the step here, I'm iterating all the available tools, right? Creating the LLM chain. This is a lang chain magic, passing the LLM and the prompt which I had created above, right? So just think, it will call the LLM model, will pass this prompt. So LLM will provide the output based on this prompt, how you want it to provide, right? So kind of RAG, a part of RAG, right? So where you control the general LLM model, passing some prompts to it and get the desired output out of it. Third is, yeah, next step is agent. I am creating a zero shot agent. I had also told you what zero shot means, no examples. But here I am using a zero shot as one shot. I'm providing one example because this is a very simple flow. And in order to get it work properly, like with fewer resources, I think it should be good to provide at least one example to LLM, so it will understand what's happening behind the scene, or it should understand how what output I'm desiring. Okay, so yeah, so here I had created the agent with zero shot agent, passing this LLM chain, whatever it was prepared above with LLM and prompt, allowed tools, all the tool names, the functions, right? So because, so as I mentioned earlier, what agent will do, it will give the user query to the LLM along with the available all tools. So a LLM will do the reasoning and will select the relevant tools for you and give it back to agent. To agent, go and use all these tools. Okay, so all the tools I'm passing to agent, and like here the execution step, where from agent and tools I'm just passing this agent tools and verbose true. This is my query. Tell me the weather in Melbourne, and then a joke. I want to know the weather in Melbourne and then hear a joke. This is a normal natural language query, right? So, and note, in example I had used what is the weather in Paris and maybe some joke, right? So now I want to know, it's a real time query. I want to know the weather in Melbourne. Let me start executing it. So yeah, if you see here, I had printed suffix and prefix. So it's a default value. Answer the following question as best you can. You have the access of following tools: get weather, tell joke, right? Begin. And this is a suffix, question and agent scratch pad. So you would see here, that's a real magic, guys, right? So you would notice based on this query, the agent is using this example and will, it's not using, it's passing, yeah, agent is using, calling LLM, and LLM using this example to find out the list of tools what they want to use, right? So LLM will say, okay, based on this example and the list you provided to me, agent, the first tool you should call get weather and then tell joke. Then agent will call these so these methods. So you would see the output should be having the weather in Melbourne is sunny and warm. So sunny and warm I had mentioned, and in example I have given it as a 15 degree centigrade. So you will see the difference. It is not as it is taking from the example, but it is based on the example, it's calling the actual tools and doing the actual execution of these functions, right? So here for example, yeah, see, I should get the weather and then tell a joke based on the example. Okay, and then get weather input is Melbourne, so the weather in Melbourne is sunny and warm. So this is the output from this method. Yeah, this get weather method, the weather in Melbourne is sunny and warm, right? So the first tool got executed, and this is the output now. And yeah, this is a text content because I'm calling the MCP server. As I told that it will provide you the standardized format, right? So this is all the magic happening via MCP server. Okay, so like it's provided in your JSON, and now the next step is it is just going to tell the joke as well. So LMs are little slow, right? So this is not going to happen in real world scenario, right? So you just need to be smart enough how you are doing it, right? So there are some optimization strategies which I'm also planning to cover going forward in future videos, like optimizing the runtime, where like what are the different ways you can optimize the runtime of inference, like like splitting the GPUs, like using the splitting the GPUs in uh, multi GPU support kind of, right? So or splitting the model across multiple GPUs, for example, right? So or not calling the LLM every time, like if there is a query which you think you might have provided to LLM, just store all that reasoning in the Redis cache, maybe, and based on some semantic similarity, you can pick pick the output from the Redis cache instead of every time going to LLM. So these all are the practices which we will discuss in our future videos. The industry level practices, how you should achieve the performance in the agentic AI flow. But this is just an example. That's why LLM was taking time. So now you see the output. The program got completed. Yeah. So what's the output, guys? So get weather Melbourne. This is the weather it got. Thought now I will tell a joke. Tell joke. Okay. Input is definitely nothing, and the output for, see, in the example the joke was like, why did AI go to school, but here the joke is the actual joke, whatever I had mentioned in the tool. Okay, just consider it's a real-time execution of this function, guys, right? So tell the joke, why did the computer go to therapy, because it had too many processing issues, right? So it had given you the actual joke out of the tool, out of the tool after executing the tool. So why did the computer go to therapy? Because it had too many processing issues, right? So that's the magic of agentic AI. It took the example, took a list of tools, gave it to LLM. LLM saw that example, provided the reasoning, the list of tools, what needs to be executed, and the order, and uh, hmm, agent took that instructions and then executed the real actual tool for you to do the certain operations. So that's how it and finished the chain with the final output. The weather in Melbourne is sunny and warm. Here is the joke, why did the computer go to therapy, and blah blah blah. So yeah, you see the work got completed, right? So now you can correlate with your real-time use cases. So there are further enhancements you can do. You can ask based on the first output, like the weather in Melbourne is sunny and warm. Now the agent say, you want me to continue further to tell you the joke? You say yes, and then it will give you a joke. So you can split that operation, and in the real time scenario, like if you ask agent uh, to bring you the Nike shoes within $1,000, it will bring like execute the tool based on the LLM reasoning, bring all that result to you. Whatever is the return type, whatever is the return of that function or tool, I would say function. Okay, provide that list to you, and then whatever you select, okay, this is the second one, this is the second SKU, this is the SKU number, please place an order for me, or either create a trolley for me. It will take that input from you, again pass all the tools to LLMs. LLM will give the agent a reasoning, and it will execute the tool, either create trolley or place order for you, and that operation will be completed. So that's the thing happening behind the scene, guys, right? So looks like pretty easy, but going beyond, there may be a further enhancement to this agentic AI flow. It's not that easy. It depends on the real world scenarios. So there may be another use case as well, where you want to maintain the memory of the conversation, like the previous output, right? Which agent you wanted to use in your further communications. So there is a yeah there is a possibility you can handle that memory or the context of the models, or you can share those context across multiple agents. So depending on the real use cases, right? So you go, once you get deep diver into the agentic AI, then you will come to know all these enhancements and all these capabilities of agentic AI, right? So how, what, and how you can do. So yeah, so that's the thing, and also what else we can do. Yeah, so let me tell you about some of the frameworks available for this. So this is from the LangChain, pretty much open source, right? So there is one more open source API, which is called Strand API. I heard that is from Amazon. It's an again open source one, but it's pretty much suitable with the Amazon models. I tried it, but I didn't find any proper open source model which was being supported. This GPT-4 all, I didn't find it. It was giving some error for me, right? So, but it was pretty much smooth for Bedrock model, but that asked me to provide some AWS key, and I did not went ahead because it could have charged me, right? So yeah, so Strand API is pretty easy. You can go on internet, and in Amazon website you can find out the actual syntax of Strand API for Agentic AI workflow. But here I had explained it using the LangChain, like some easily available APIs, right? So this is all about agentic AI at a very high level. As I mentioned, I would be discussing more about the best inference practices, either for agentic AI or normal AI in production, like by splitting the model into multiple GPUs, or whatever is the best way. Like in AWS also, there are a lot many things like multi GPU endpoint, SageMaker endpoint you can use, and you can also use distillation of the models, right? So where you know uh, you can squeeze the size of the model. So there are different things we'll discuss, how you can design the real world, or how you can deploy the real world API models, not API, AI models for inference and all. But yeah, coming back to agentic AI, this is a very high level mm, about the agentic AI workflow. It uses the existing AI model to do the reasoning and do a task for you. And definitely, we'll keep on exploring more. I'll be providing more advanced use cases and stuff continuously about agentic AI to you guys. That will be definitely helpful for you. And that's it. Thanks.